Hi everybody, here we're going to go over the instructions for the Joule heating lab. So let's go ahead and look at the general outline for the lab. There's only one part, and you're going to take some measurements and you'll do some calculations, and then you'll create a graph. So let's go ahead and look at the data taking part. So if you click on this link here, this is what you're going to find. So you have a power supply, you have your ammeter, you have an immersion here, which is basically a resistor, graduated calorimeter that has water inside, and you have a thermometer here connected to it. So what you're going to do is you're going to run a current through the circuit. The circuit is going to heat up the water, and you're going to measure the amount of heat that's transferred from the resistor to the water. So there's a couple of settings you have to do first. You can adjust the water level, and notice that the water is you're not reading the mass of the water. You're reading the volume of the water. So you'll have to record the volume and then convert that to a mass using the density of water. Before you start the experiment, you don't want to put too much power in a circuit, and the way you do that is don't turn on the power supply yet. You can adjust these knobs here, the little white knobs on the bottom right and bottom left. And in this circuit here, it doesn't go to the middle, so I suggest putting it in this section over here, so it's just left of the middle reading. And so what you're going to do first is you can record the volume of the water and then the initial temperature of the water. So if you go here, I guess let me try to just put them off like this. So you'll record the volume of the water and the initial temperature of the water. So over here. And then next, you're almost ready to, I believe you're ready to begin the experiment. So what you'll do is you're going to turn on the power supply. And as soon as you turn on the power supply, then current is going to pass through the circuit, and the temperature in the resistor is going to heat up the water. So also here, the water is going to start off at the same temperature. Here. So as the current runs, you're going to record three things: temperature, current, and volume. So you turn on the power supply, and as you notice, time is already ticking. So you have the initial voltage, and this is going to be the current in the circuit. So record these here, so the voltage and the current. And so at each interval here, so after 60 seconds, 120, so and so on, all the way down to 540 seconds, you're going to record the corresponding temperature, voltage, and current. So it's going to take some time to get to 60, but for example, at 60, you record the corresponding temperature and the corresponding voltage and the corresponding current, and you're just going to fill in this table here, and that's going to be, and you're gonna do this all the way up to 540 seconds. And once you reach 540 seconds, what you're going to do is you're going to turn off the power supply, but you're still going to record temperature. So you're going to keep on watching until the temperature reaches a maximum. And here the maximum looks like it's about 17.1. After that, it's probably going to start to go down. So you record the maximum temperature reached over here. And that's going to complete the data taking section. So once you've gotten the data taking section, then you're going to go to the calculations. So here what you want to calculate is the temperature difference between the temperatures you measured relative to the initial temperature, and you're going to record those over here. Let me zoom in. And you'll calculate the mass of water using the reference equations. You have the density of water here given. And these currents and voltages, they should remain constant. It's just to keep track to see that they do. So once you've gotten, once the experiment is complete, then here you're going to record the average of these currents, and this voltage here is going to be the average of these voltages here. And now what you're going to do is you're going to use this current and this voltage, and you're going to use, let's see here, this equation here, the heat out, to measure the heat or to calculate the heat out from the resistor. And that's going to go here. And next, what you're going to do is you're going to create a graph. And the graph is based on this equation here. You're going to plot temperature difference versus time. And the slope is going to be this factor here. So voltage, current, mass over a specific heat. So you're going to make a plot of temperature difference versus, oh, right here, well, here, time. And so you should get a straight line, and you're going to enter that graph here. And the slope of that straight line, you're going to put over here. And once you've gotten that slope, actually, let's go. So that's going to complete section 7 and section 8. So now let's go to section 9. So in section 9, you're going to look up the theoretical specific heat for water. See water theo. You're going to use this reference here. And the experimental specific heat for water, you have to go back here, and you have to use this equation. So here the slope corresponds to voltage, current over mass, and specific heat. So once you've gotten a slope from the graph, you'll do some algebra and solve this equation here for the specific heat, C, right there, and that's going to give you the experimental specific heat. And that's what's going to go over here. And you'll also calculate the error in the specific heat using the reference formulas. So this one over here. And let's see what's next. Also percent differences. And also now you can calculate the heat into the circuit. And you're going to use this equation over here to calculate the heat in. So it's going to be the mass of the water that you calculated, the experimental specific heat that you got from solving this equation, and then the difference in temperature, the maximum difference in temperature. And once you have that, then you're going to record that over here as a heat in, and you're going to complete the experiment by taking a percent or comparing the heat that you calculated using the slope of the trend line, and then the heat that you calculated using the electric circuit components. And you're going to record that over here. And once you've done that, then that will complete the Joule heating experiment.